Last class it was about oxidation number, and today we are starting off with nomenclature. What does simply nomenclature means? It's naming, right? So under naming, we're going to learn around 6 categories. The first one is going to be monoatomic ions. Under monoatomic ions, let me start the examples that I have took. Sodium chloride, magnesium oxide, and cesium bromide. Now I say this is sodium chloride and this is magnesium oxide and this is cesium bromide. The rule for naming these monoatomic ion is, first we write the name of the cation. Second, we write the anion name, but we end it with ide. See, this is the anion, so we end the name with ide, and there should be a gap between the cation and anion name. These are the 3 rules under monoatomic ion. The second category is cations forming more than one charge. So for the cations forming more than one charge, we give IUPAC or the trivial names. When it comes to cations forming more than one charge, they are usually transition metals. Transition metals are the cations that forms more than one charge. For example, copper, iron, and lead, tin. Okay, for them we name using IUPAC or trivial method. First of all, when I take IUPAC system, here the rule is we have to first of all write the metal name and add the oxidation number within the brackets. Oxidation number within brackets, and we do not leave space between the name and the bracket, and then comes the anion name. This order, if you could remember, that's more than enough. Let me show the example. If I take this, okay, we write it as iron 2 sulfide. Let me take another example, that is Fe2S3. That means iron 3 sulfide. This is how we name them. And then if I take this, we name it as copper chloride. This is the rule. Here it should end with ide. First of all, we write the metal name and then oxidation number within the brackets. There should not be space between them. And then we write the anion name that ends with ide. See? So trivial system, it is not like commonly used, but we use it in some cases when there is lower oxidation state. We end with OUS. And if there is high oxidation state, we end it with IC. Let me list out some examples. Now when it is low oxidation state, it ends with US, and if it is high oxidation state, it ends with IC. Now here, Fe2 plus is ferrous, and Fe3 plus is ferric. Likewise, copper plus, Cu plus, is cuprous, and if it is Cu2 plus, that is cupric. And the tin, right? If it is 2 plus, we say stannous, and if it is 4 plus, we say stannic. And the lead 2 plus, is plumbous, and lead 4 plus is plumbic. Only these things are these days used. So that's all on trivial system. Okay. Now cations forming more than one charge, they are transition metals like copper, iron, lead, and tin. So there are two methods to name them. That is, one is IUPAC method or IUPAC system and trivial system. So this is how we name them. This is the IUPAC system and this is trivial system. Okay. Moving on to the third category, simple covalent compounds. Carbon monoxide and hydrogen sulfide, SO3 into O3 into O4, and then P4O6 H2O, and then OF2. Now let me name them according to the nomenclature. This is carbon monoxide. This is dihydrogen monosulfide. And this is sulfur trioxide. This is dinitrogen trioxide. And this is dinitrogen teroxide. This is tetraphosphorus hexoxide, right? 6 now hexoxide. Dihydrogen monoxide. And this is oxygen 2 in a sense, difluoride, no? Yeah. Okay, so this is how we name the simple covalent compounds, and the rules for naming them is the positive oxidation no elements, number elements comes first. Now see here, out of carbon and oxygen, carbon is positive, oxygen is negative, right? So the positive oxidation number, right, the positive oxidation number element is coming first, and the negative oxidation number element comes second. The first and the second rule. The third rule is we have to give a gap between those two terms. Now this is the positive oxidation number element and this is the negative oxidation number element. There should be gap between them. Okay, I have mistaken here. There should be gap here, gap, gap, gap. Okay, and then the fourth one is the most electronegative element ends with ide. The most electronegative element in the sense the negative oxidation number elements. So see here, the negative oxidation number element here is oxygen, so it ends with oxide. Here also oxygen ends with oxide. Here as well oxygen ends with oxide. Here hydrogen is plus, so it comes first, and sulfur is negative, so it comes second, and it ends with ide because it is more electronegative when compared to hydrogen. And here there's a special case. Let me write it in a different color. The special case is we use prefixes for the number of atoms, right? We use prefixes for the number of atoms. Now see here, if I take this example, see, according to this rule, there are 2 hydrogen, so we say dihydrogen, okay? Since it's 2 hydrogen, we say dihydrogen, and the sulfur, there's only 1 sulfur, okay? So we say monosulfide. So we use prefixes for the number of atoms. So the prefixes are like this. If it is 1, it's going to be mono. If it is 2, it's going to be di. If it is 3, it's going to be tri. If it is 4, it's going to be tetra. And if it is 5, it's going to be penta. If it is 6, it's going to be hexa. And if it is 7, it's going to be hepta. And if it is 8, it's going to be octa. It's all under simple covalent compounds. The next category is polyatomic ions. Polyatomic ions. So our polyatomic ions, these are the example I have took. Potassium dichromate. Let me write the chemical formula first. How do we call this one? We say potassium dichromate, right? So the rule for polyatomic ions is the polyatomic cation will end in M, and the anion will end in one among this, ide, or ate. Okay, one among this, ide, or ate. See here, potassium dichromate. Likewise, this is ammonium dichromate. Here also the cation. Cation is ending with M, and the anion is ending with 8. And then this one is potassium dihydrogen phosphate. And then the next example, here also Am8. Iron 2 oxalate. It's ending in 8. And this is sodium hydrogen carbonate. So this is how we name polyatomic ions. Em and 8. Remember the rule, polyatomic cation ends in em, polyatomic anion ends in ide, or ate. Next category is inorganic acids. It's two categories. One is with oxygen and without oxygen. The examples are with oxygen, H2SO4 and H2SO3. Without oxygen, HCl, HBr, HCN, H2S. Oxygen is going to be anion, right? Oxygen is going to be the anion here. So if the inorganic acid is having oxygen, then we call it as oxo acids. Okay, inorganic acids with the anion oxygen means that is oxo acid. In that case, ends in ate mean it's ick, and in ite mean us. Now let me clarify this. Now if I take this example, this is H2SO4. That means this is sulfate. Here the anion is sulfate. So if the anion is ending in ate, it is ick. Here sulfuric acid. Now if I take this example here, SO3, right, which means it is sulfite. So if it is ends in ite, we call it as sulfurous acid. Here, since SO4, right, it is sulfate, it ends in ate, it is sulfuric acid. Remember that, the anion, okay? Here the rule is anion without oxygen, in the sense we call it hydro. Here non-metal, or else I can call it as group of non-metal, will end with ick. So let's name these examples. This is hydrochloric acid. This is hydrobromic acid, right? And this is hydrocyanic acid, and this is hydrosulfuric acid. Okay, and if you guys need these notes that I write, please DM me through any one of the platform. You can access them freely. And last but not least is oxo anions, or else we call them as oxy anions sometimes. So both are same, oxo anions or oxy anions, both are same. They are we learn polyatomic ions now. Here they are polyatomic ions, right? They are polyatomic ions, but they contain oxygen. That's it, we say oxo anions or oxy anions. Here there are some base elements, right, like usual ones. They are nitrates, sulfates and chlorates. Rules for them are, there are two rules. Okay, the first rule is 8 or 8. First row is 8 or 8. If same elements are forming two oxyanions, more oxygen in the sense, it will end in 8. And if it is less oxygen, it will end in 8. Now let me take an example for nitrate series. If I take this and this, if there is more oxygen, it will end in 8. So here nitrate. And if there is less oxygen, it will end in 8. So this is nitrite. Likewise, if I take sulfur series, SO4 2 minus and SO3 2 minus, here this one has more oxygen, so this will end in 8, sulfate. This has less oxygen, so it ends in sulfite. This is the rule number 1, that is 8 8. Rule number 2 is, I'm going to write this, per or hypo. Okay, rule number 2 is per or hypo. This is used when 4 forms exist. It's like if I take let me take the chlorine, right? Okay, chlorine series, like 4 forms. No form, there is 1 form, the second form, the third one, and then 4th one. So these are the 4 forms. This one has most number of oxygen, and here 1 less, here also 1 less, and here it is least number of oxygen is there in these compounds. Okay, now the prefixes are the suffix. Prefix are the suffixes for them. Okay, most oxygen in the sense, it will start with per, ends with 8. If it is least, it will start with hypo and then end with 8. 8. This is 8. Okay, if the oxygen number is high, that is 8. If the oxygen number is less, that is 8. So see here, if this one has 4 oxygen, this one has 3 oxygen, this one has 2 oxygen, and this is 1 oxygen. Now let me name them. Chloride. This is chloride. ClO2 minus is chloride. ClO3 minus is chlorate. And this is perchlorate. So with that, the nomenclature is ending. Remember these things. These are very, very crucial. And with that, the part 2 of chemical calculation is ending. See you in the next video. Stay tuned. And if you are watching without subscribing, please do subscribe and support us.